Hello everyone. In this lecture, we will learn how to reconstruct the approximation and detail of a 1D signal from their coefficients at the first level decomposition using discrete wavelet transform. Okay. We have already learned how to decompose a signal into one level approximation and detail coefficient. I just copy the codes here and write it because I will use the CE1 and CD1, the approximation and detail coefficient to reconstruct the approximation and detail of the signal S. Okay. The first method is upcoef method. Probably you still remember we learning the methods called downcoef. Downcoef is for the decomposition, the partial decomposition. Yeah, we already learned this. Yeah. Here, the upcoef is just the opposite story of the downcoef. Okay. Upcoef function can directly reconstruct the level 1 approximation and detail A1 and D1 from their coefficients CE1 and CD1. C1, CD1. There are some parameters. Part, the input coefficient type. A refers to approximation, reconstruction is performed. That means if we set to A, that means we will perform approximation, reconstruction. If we set it to D, that means we will reconstruct the detail. Okay, it's just the opposite to the downcoef. Just now we already talked about. And the coefs is, in fact, here are because there's two coefficients array to reconstruct. That means the CE1 and CD1 here. Wavelet refers to the name of wavelet that we use in the transform. Level, if level is specified, then a multi-level reconstruction is performed. The default level is 1. That means we reconstruct the approximation and detail from one level or single level decomposition efficient. Here means if 2 or more value are set here. Yeah, 2, 3, or 4. Another is take 0. 0 is the default. Take means we take some numbers. Yeah, if that means, for example, yeah, this description is a little bit awkward in the document. I have no ideas how to make it more better a better description, but I explain it here. Take 0, that means we keep all the values. If we set it to 1, that means we only take one value from the central part. If we set it to 2, then we take 2 from the central part. of the value. You will be more clear when we use the example. I can show you when we change the value of take. Here we usually take the length of the original signal. Yeah. Let's see the example. Okay. Now we are just we already import the PyWT. Here's no necessary to import it again. We just want to get A1. A1, here's PyWT dot up to if, okay, the part, because it is approximation thing, we set it to A. And another is coefficient, is CA1, the approximation coefficient. Wavelet name, here we use the same. Please be remember, we should use the same wavelet as what we use in the decomposition process. So here we use dB2, okay? Then another is level. Because we are the first level, only single level, we take level 1. Just now I said the take, for take, we set to the length of S. Okay. Then let's reconstruct D1. So D1, we set to D, we set to CD1, dB2 level, others the same. No less print. A1, we print B1, okay? No less print. There's some error. No up coef. You see, mistake. Here is mistake. There's only one F, but I type 2F. So be careful here. No, you see, we got this approximation. The first array, the second are details, D1. Just now I said the tick. Let's try. Let's try. We add. We just copy and see the difference. For example, here we set to 2. You can try others in order to understand what it is. Okay. For example, we set it to 2. You see, we only take 2 from the middle part, 5, 6, and also 2.4. You see, only take 2. If you set it to 1, then there are only 1. So you can try, and then you will be clear. Okay. For us, we set it to length S because we wanted to take the numbers exactly equal to the length of original signal. Okay, length. No, let's see. Sometimes we use, when we decompose, we use coefs instead of CD1. I mentioned this in previous lecture. If you you still remember the co-ifs like this, right? Right? So we will do in this way. CE1 is the co-if 0, means we take the first array from the co-ifs. The co-ifs contains CE1 and CD1. Here is the co-ifs 1. Okay, you see the same result. Yeah, you can use choose one of them that you like. Okay. The second method is inverse discrete wavelet transform method. Maybe you still remember we use here the inverse discrete wavelet transform to reconstruct the whole signal. Here is only part of the story. During the reconstruct the first level approximation and detail, the concepts and the process, we talked about this. You see, when reconstruct approximation A1 from the coefficient vector CE1, we want to get A1 from CE1, we fit in a vector of 0 in place of the detail coefficient vector CD1. See, here we set a vector of 0. See, this is just the story that we use here. For the reconstructed detail D1 from the coefficient vector CD1, we fit in a vector of 0 in place the approximation coefficient vector CE1 here. So let's come back to do it. Here I use E because I want to compare these two methods and see if there are any difference. Okay. Here we use PyWT inverse discrete wavelet transform IDWT. See this one, but in inverse discrete wavelet transform to the whole signal, we use CACD, but here we only use one, another fit in 0 vector. Okay. A because so we keep C, but another CD is CD1 because here we use 1, right? Yeah. The decomposition here 1. Yeah, you can use a CACD, but here I just means we reconstruct from the first level of decomposition. So here we can use that now. This that means is 0 vector. It equals this. It all depends on the length. Maybe you still remember the length of CE or CE1 and CD1 is 6, right? Yeah, you can calculate. Here is equal to 6 zeros, the length of CD1. Yeah, is equal to this. We will talk about this in other courses, maybe in the future, in some advanced method, or maybe next, I think in the project, yeah, we will use a NumPy to set up a zero array. Okay, here you can use none. Then another parameter, so wavelet mode, these two. Yeah, we use db2, the same one that we use in the decomposition. Another one is the mode. Here we use the, let's go back, the symmetric, the sim. Remember the sim, wavelet, sim, mode. Okay, this is the A. For D, the same, but we feed, we change D first. We feed the CA to now. That means the zero vector. Here is our CD1. Remember the order. Yeah, because we CA first, CD second, not change the order. Okay? Or it will be wrong reconstruction. We print A, we print D, because they are only ones, one level, so A1, D1, or A and D makes no difference. Okay, just the variable name. Let's print. You see, because this example is so simple, we can see directly these two are no difference if you compare. But for the real world project or real case, the data, the signal is very long. Yes. So we can compare. We can use very simple method to see if these two methods have any difference. We can do in this way. For example, A minus A1 print D minus D1. You see, all zero. That means they are the same. But of course, for long signal, we can do, maybe we use the average. Oops. We divide the length as the signal. I mean, if the signal is too long, we can't calculate C if any element is 0. Anyhow, this is very simple. I think you already know all this process. Okay. Now let's see. S is capitalized, so we should use the same. is the same as divided by length. Oh, we use sum, right? Sum the difference, then divided by the length of signal. See, 0, 0. Okay. Thank you. See you in next lecture.